All right, today we are going to be learning about geometric series. So let's start with some vocab. Starting with a series in general. A series is the expression formed by adding the terms of a sequence. A geometric series specifically is the expression formed by adding the terms of a geometric sequence. And if we remember back to Algebra 1, a geometric sequence, those are the sequences that have a common ratio between them. And we call that common ratio R. So what that means is a geometric sequence is a list of numbers that we multiply each number to find the next number in the sequence. And the number that we continuously multiply by, that's our common ratio. So the following are all examples of geometric sequences. Let's try to find the common ratio for each. So for example 1, I have 3, 6, 12, 24, 48, and it would continue to go on and on and on. So let's think. What do I need to multiply 3 by to get 6? 3 times 2 is 6. All right, let's make sure that works for everything. Is 6 times 2 12? Yes. And 12 times 2 is 24, and 24 times 2 is 48. So R is, in fact, 2. Now, sometimes it's a little bit harder to just think about it. So we can use math to find the common ratio as well. So for example, 2. I've got 4, 12, 36, 108, and 324. Another way to do this is by taking two consecutive terms and dividing the second term by the first term. So 12 divided by 4 equals 3. And so the common ratio is 3. Now you can always check just to make sure. 4 times 3 is 12. 12 times 3 is 26, and so on and so on. So the ratio is 3. Now for example number 3, notice that in this sequence, we are getting smaller. It goes 2, 1, 1/2, 1/4. Instead of trying to think about it, we can just use our dividing trick. We're going to pick two consecutive terms, and divide the second term by the first term. So 1 divided by 2, that's just 1/2. So the common ratio here is 1/2. And we can try to make sure this works. So 2 times 1/2 is 1. 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4, and so on. All right, so these were all examples of geometric sequences. Now remember in Algebra 1, you learned for a geometric sequence, you can use a formula to find any specific term. So right now in front of us, we have just the first 5 terms of these 3 sequences. But what if you wanted to find the 10th term? Instead of having to multiply it out again and again and again and again, we can use this formula. So now in this formula, I want to highlight a few special pieces. A sub 1. A sub 1 is the first term. The next one, we just learned about R. We know that R is our common ratio. And the last variable we have is n. And you notice that n actually shows up in 2 places. It's here, but it's also the subscript of the A in front. So n is the number term that we want. We want to find the nth term. And then A sub n, that whole thing together, that is the nth term. So maybe I could even rewrite this a little bit. Instead of that being called the nth term, nth is the number of the term. All right, so let's write the formula for the 10th term from example 1, 2, and 3. So for example 1, for A sub 10, we're going to start with A sub 1, the first term. So the first term in example 1 is 3. So we have 3 times R. Well, we determined that R was 2 for example 1. To the n minus 1 power. Again, our n is 10, so to the 10 minus 1 power. If I wanted to simplify this, this is 3 times 2 to the 9th power. Now I'm going to leave it like this because it just says to write the formula. It doesn't say to actually find. Oh, it does. It says, and then find the 10th term. All right, so now I'm going to plug it into my calculator. 3 times 2 to the 9th term. I get 1,536. All right, the second example. Our first term for example 2 is 4. So equals 4 times r, which we determined was 3, to the n minus 1 power. So 4 times 3 to the 9th power. Again, I'm going to use my calculator. Make sure when you plug it in, you do 4, parentheses, 3 to the 9th power, parentheses, enter. And I get 78,732. Sorry, guys. All right, and the last one for example 3. Again, I'm going to start with the first term, which is 2. So 2 times r, which is 1/2, to the n minus 1 power. So this becomes 2 times 1/2 to the 9th power. I'm going to plug it into my calculator. Be careful when you plug it into your calculator. If you don't have the fraction button, you might need some parentheses there. And I get 1/256. Now, if your calculator gave you a decimal, remember you can hit math, enter, enter in order to get the fraction. And because our sequence is in fractions, it would be good to write our term as a fraction as well. All right, so moving on, with geometric sequences, we are, actually, I want to change this word. We're moving on to geometric series. So change this word in your notes. This should say geometric series. So a geometric series is an expression that's written as the sum of the terms of a geometric sequence. So now instead of commas in between them, we see plus signs in between all of the different terms. When we have a geometric series, we are finding the sum of a finite number of terms, so specific number of terms. The notation for sum, the symbol that we are going to use is S with a subscript, and that subscript depends on which term you're finding. So if we're going to find the sum of the first n terms, this is going to be S sub n. Okay, so let's putting this into practice. Blank would be the notation for the sum of the first 5 terms. Okay, well, the first 5 terms, that tells me that I should put 5 as the subscript, S sub 5. All right, so right here it says find the sum of the first 5 terms. So again, I'm filling in my notation here, S sub 5. For the sequence series 3 plus 6 plus 12 plus 24 plus 48. If you add those all up, you get 93. All right, we got it. Now, for the same series, calculate the sum of the first 25 terms. Yikes. That would be difficult. I would have to first find the first 25 terms, and then I would have to add them all up. And that is a lot of work. It sure would be helpful if instead we had a formula for this. This is where I'll pick up in the next video.